Okay, for the next question is given that stone of mass 5 kg falls from the top of a cliff. So the mass is 5 kg and it falls from the top of the cliff and covers a distance of 50 meter. So if it falls from the cliff, that means the initial velocity is zero and buries 1 meter in sand. So that let's say the final velocity before it buries in the sand to a distance of 1 meter, that it be v. Okay, so let's consider this first case when it falls from the cliff and before it just touches the sand. So the mass is 5 kg, distance covered is 50 meter, initial velocity is zero, and let's calculate the final velocity before it buries itself in the sand. So we have to calculate v. Okay, now the distance is given, so we are going to use uh, the equation v square minus u square is equal to 2as. We have to calculate v and u is 0. Acceleration, let's take it as acceleration will be acceleration due to gravity and it will be positive because it's in the downward direction. So acceleration is 9.8 meter per second square. So this is 9.8 and distance is 50. So v square is equal to 2 into 5 into 20 is 100 and 100 into 9, 8 is 980 meter per second is the v square. So let's just keep it as v will be the under root of 980 meter per second. Okay, so this is the velocity before it penetrates into the sand. So that is under root 980 meter per second. Okay, now this velocity for when it penetrates into the sand. So this will be the initial velocity when it penetrates 1 meter into the sand. So this is the initial velocity for that. And when it goes to 1 meter, it comes to it, the final velocity would be zero. And we have to calculate the average resistive force offered by the sand and time it takes to penetrate. So we are once going to use uh, let's find out uh, the, the penetrative force or the resistive force offered by the sand. So when the stone is penetrating into the sand, let's once again use this equation, which is v square minus u square is equal to 2as. And let's keep this, for this, the distance is 1 meter. So for penetrating the sand, let's once again use v square minus u square, or let me just write down. So here for penetrating the sand, the u is under root of 980 meter per second. Final velocity is zero and the distance is 1 meter. Okay, so it's v square minus u square is equal to 2as. V is 0, u is under root of 980. Square root gets cancelled with 2 square. So 2 into a into distance is 1 meter. So this is negative 180 is equal to 2 into a, and a is equal to negative 490 meter per second square. Negative means it's a retardation. Okay, now let's calculate the resistive force. The resistive force offered by the sand would be mass into acceleration. Mass of the stone is 5 kg. So this is 5 into minus 4.90 Newton. And that is equal to 5 0 that is 0, 9 5 is 45, 5 4 are 20, and 24. This is negative 2450 Newton. Okay, now we have to calculate the time as well. So this is the resistive force offered by the sand. We have to calculate the time it takes to penetrate. So let's use V is equal to U plus AT, and the final velocity when it penetrates into the sand is zero. Initial velocity is the root of 980 the acceleration was minus 490 into t, or we can also use s is equal to ut plus half at square. Okay, let's try to use this. This is under root 980 is equal to negative 490 into t. So this gets cancelled. Negative negative gets cancelled. So t is equal to under root 980 divided by 490. And under root 980, let's calculate under root 980. So under root 980, okay, that will give us the value 31 point. So the under root 980 is 31.30. It has to be divided by 480. And if we divide 31.30 by 480, it has to be divided by 480. So which gives us 0.0652. So 0.065 seconds would be the time. Okay, with this, we are done with this question. Do like, share, and subscribe. Thank you for watching.